So let r tends to 0. Let r tends to 0, that previous equation, this equation becomes r tends to 0 means we can cancel it out. R tends to 0. So we can, this will be very, very small. So we can cancel it out. So this equation becomes exactly like this. Is it okay? Now I can pull, this is constant, f of z0 is constant, I have pulled out. So 0 to 2 pi d theta, if you are going to integrate d theta, that will be theta, substitute lower and upper limits, that will give you 2 pi. So 2 pi I f of z0. Is it okay? Very simple. Instead of theta, just substitute 2 pi and 0. See, 2 pi and 0. So that means 2 pi I f z0. So f of z0 equals 1 divided by 2 pi integration of f of z divided by z minus z0 dz. This is your Cauchy's integral formula. This is your Cauchy's integral formula. Any doubt? Very, very important formula. We are going to use this formula to solve many problems. Suppose instead of z0 you can have a, b, c, any number. So that will be, instead of z0 you substitute a, instead of z0 that will become a. That's all. Same formula. Instead of z0 there will be a. That's all. You can write either formula like this or like this. So this is your Cauchy's integral formula. Okay. Now we will solve so many problems. We are going to solve many problems. Problem number 1. Remember this formula. Okay, this is f of z0 equals 1 divided by 2 pi integration of f of z minus z0. Either you remember this formula or this formula, both are the same. Okay, and we are going to solve the integration exactly of this type. Look at the integration, z divided by z minus 2 dz. Look at this one, f of z divided by z minus z0 dz. See, both are of same type. This is of same type. This one and that one. Your f of z will be z minus z0. Z minus z0. So z0 is 2. That's all. Is it okay? So look at this formula and compare this one. Immediately you can say that z0 equal to 2. Immediately. Your f of z will be your z. You can compare. We will see. Where C is a circle, z minus 2. So z minus 2. What of the origin? 2. Very good. Z minus 2. The origin goes with 2. Okay. What of the radius? 5 by 2. Okay. Z minus 2. So z minus 2 equals 0. So z equals 2. What about 5 by 2? Radius is 5 by 2. 5 by 2 is more than 2 or what? Your z0 equal to 2. Your radius is 5 by 2. 2.5. So the answer will exist or not? It will not exist. See, radius is 5 by 2, 2.5. Okay. What is z? Z equal to 2. Answer will exist or not? Come on. See here, your radius is 2.5. Z equal to 2. 2 is inside. So whether it will exist or not? It will exist. Analytic solution. Simple idea. This is what you said. So radius is 2.5. Radius is 2.5. But Z equals 2, which lies inside the radius. Radius of 2.5. The answer that we are going to get, let us see how it goes. We will see. So here it's a detailed sum. Here the integration is exactly like this. And C is a circle with a center 2, 0. Okay, 2, 0. And the radius will be 5 by 2. Here Z equal to 2 lies inside C. And your f of Z equal to Z. F of Z is analytic everywhere inside on C. And by Cauchy's integral formula we know this. So we just now we have seen this one. Okay, we know. So your f of Z divided by Z minus A dz equals 2 pi I f of A. Instead of Z0 you can write A, doesn't matter. So this one will be your Z0 will be 2. So f of 2. Correct? F of 2. So you have Z divided by Z minus 2 dz will be 2 pi multiplied by 2. What is Z? What is Z? Z equal to 2. You substitute 2 here. That also. So you will have 2 pi 2. Instead of f of Z, you will have to substitute Z. f of z. This is your f of z. Is it clear? This is your f of z. F of z equals z. F of 2 will be 2. Z equal to 2. So the answer will be 2. 2 multiplied by 2 pi will be 4 pi. So 4 pi is the answer. Any doubt? So this function is analytic. We will see few problems. If you do it, it will be very easier for you to understand. We will go for problem number 2. Okay. So now dz divided by z squared minus 7z plus 2. What of the z? What of the origin? It exactly starts from mod z. What of the origin? 0 0 0 0. It's very simple. 0 0. See, in earlier problem, it is z minus 2. The origin starts from 2. Now here it is mod z. Simply. So origin starts from 0 0. What are the radius? 3.5. So remember these two. So now here it is not z minus 2 or z plus 2. This is your quadratic equation, z squared minus 7z plus 2. That can be separated into z minus 4, z minus 3. You can fraction, you can separate this one, quadratic equation, into z minus 4, z minus 3. Is it okay? Now look at this term. This can be written as 1 divided by z minus 4 divided by z minus 3. I can write 1 divided by z minus 3 divided by z minus 4 also. Both ways I can write. Is it correct? So this can be written as, this term can be written as 1 divided by z minus 4 divided by z minus 3, or 1 divided by z minus 3 divided by z minus 4. Suppose if it is z minus 4, suppose for example, if it is z minus 4, what of z naught? 4. What are the radius? Whether it will exist or not? No, it not exist. So it must analytic. So that's why I written like this. So now there exists solution. In earlier case it's not solution. So that's the reason that I have written as 1 divided by z minus 4 divided by z minus 3. Z minus 3. So now z equals 3. If it is z equal to 3, so the radius lies inside, radius is outside, so the analytic function is inside, so surely it will exist. So here C is a circle with the center 0 0 and radius 3.5. Z equal to 3 lies inside C. So let f of z equals 1 divided by z minus 4. Okay, so this is your f of z. This is your f of z divided by z minus 3 dz. So now by Cauchy's integral formula, we can write f of z divided by z minus a dz equal to 2 pi I f of a. So this is Cauchy's integral. So this is your f of z. F of z is nothing but 1 divided by 3 minus 4. F of z is nothing but 1 divided by z minus 4. Already z equal to 3. So that's why 3 minus 4. See, that's why 3 minus 4. 3 minus 4 is minus 1. So minus 1. So the answer is minus 1 multiplied by 2 pi I will give you minus 2 pi I. Simple problem. Is it okay? So here analytic solution exists. Okay? In one term analytic solution doesn't exist. So that's why we have taken the other term. Any doubt? Simple problem. Now we will go for problem number 3. So integration dz by z square plus z. So z square plus z immediately says that there will be two answers for z. Z squared is there. So two solutions must be there. If it is simply z, there will be only one solution. If it is z squared, two solutions must be there. If it is z cube, three solutions must be there. Simple idea. So you have z squared plus z. You make z squared plus z equal to 0. You pull z common out. So z plus 1 equal to 0. So it implies that z equal to 0 or z equal to minus 1. Very simple. So you have one solution is here, then another solution is here. Now we are going to separate. Yeah, for one solution z equal to 0, then another solution z equal to minus 1. We are going to separate now. So as the radius z is greater than 1, both the simple poles lie within the region. It's very clear. What is the radius? Radius is greater than 1. What is the solution? your z0 also 0 and z0 also will be minus 1. So both will lie inside the circle, inside of radius mod z is greater than 1. So we have two solutions. So we have two poles, so simple poles lie within the region. Okay, so now we are going to do this one using partial function, partial integration we are going to do. Okay, so this is for C1 and this is for C2. Now 1 by z square plus z, just take this one alone, 1 divided by z square plus z, so which is written as 1 divided by z plus 1, partial integration is a divided by z plus b divided by z plus 1. Probably you would have studied in partial differentiation earlier in your mathematical classes, maybe in undergraduate, okay, or in plus 2, a divided by z plus b divided by z plus 1. So now just take the LCM. So a multiplied by z plus 1, b multiplied by z. These you have to compare with this one. So 1 equals a z plus 1 plus b z. I repeat, just take the LCM right here. Left hand side, just write the numerator. That's all. Okay. What are the denominator? Both will get cancelled. So you have to compare with the numerator. So just take the LCM and compare with this one. So you will have 1 equals a z plus 1 plus b z. Now we know we have got two solutions, z equal to 0, then another solution will be z equals minus 1. So first z equal to 0, you substitute here, z equal to 0. If z equal to 0, this term will go off, z equal to 0, a equals 1, so a equals 1. Second one is z equals minus 1, so minus 1 means a will go off. We can get the value for b equals minus 1. See, now we have found out the value of a and b. That is the beauty of partial integration, partial fraction. See, that's a beauty. We can separately we can do. See, integrating this one is very tedious. Integration of this one is very simple. See, that's the reason. This is very tedious. Z square plus z is very tedious. Whereas integration of z is very simple. 1 by z plus 1 also is very simple. That's why you always go with partial fraction. Okay. So now both the integral becomes both the integral. See, the earlier this one and this one becomes exactly like this. Okay. So using Cauchy's integral formula, we know about Cauchy's integral formula, which is equal to 2 pi I f of z naught. We are going to go with first one plus we are going to go with the second one. Now this is your first integral, this is your second integral. Okay. This is your f of z. F of z is nothing but 1 here. Is it okay? F of z. F of z is nothing but 1. So 2 pi I, the formula is 2 pi I, where f of z equal to 1. So the first one will be 1 divided by z plus 1. What is the first solution? So z equal to 0 plus 2 pi I 1 by z. What is the second solution? Minus 1. Okay, now you substitute here. So this will be 2 pi I multiplied by 1 plus 2 pi I multiplied by minus 1. The answer is 0. So the integral answer is 0. Okay. Any doubt? Any doubt? Okay, it's very simple one. Okay, z equal to 0 and z equal to minus 1. And this is for your a and this is for your b. Okay, see, this is for a and this is for your b. A and b. So we have converted into a and b like this. Okay, we will solve one more problem, you will find out. Again, this problem exactly with a partial fraction. Immediately you should remember z squared minus 1, no other way. We will have to only go with the partial fraction. So now we are going to solve. What are the radius? Radius equal to 1. Okay. So z squared plus 1 divided by z squared minus 1 has the poles at z equal to 0 is given by z squared minus 1 equals 0. So z equals plus or minus 1. Z equals plus or minus 1. So you have z squared plus 1 divided by z squared minus 1, which is equal to, we can write this as a divided by z plus 1 plus b divided by z minus 1. So you can write exactly z squared minus 1 can be written as z plus 1 z minus 1. Now take the LCM. take the LCM. So z plus 1, z minus 1, and you are going to take the LCM. So this becomes a multiplied by z minus 1 plus b multiplied by z plus. Now you have to compare with the numerator, as I said earlier. Denominator will be cancelled. You have to compare only with the numerator. So z square plus 1 equals a z minus 1 plus b z plus 1. Okay. So if z equals 1, plus or minus 1, we will see. Okay, if z equal to 1. If z equal to 1, this term will get cancelled. It will become 0. What about b? b multiplied by 2. b multiplied by 2 because z equal to 1. So 2b. This side you have 1 plus 1, 2. 2 will get cancelled. So b equals 1. I repeat, z equal to 1. This term will go off. You have 1 plus 1, 2. Here also 1 plus 1, 2. So these 2 and these 2 will get cancelled. Your b will be 1. For z equal to minus 1. For z equal to minus 1, you will not get this. You will have minus 1, so minus 2. What is this term? This term 2, very good, 2. So minus 2a equals 2. So a will be minus 1. Minus 1 squared. So plus 1 it will become plus 1. So you have found out now the value of a and b. You have found out the value of a and b, which is very important. So now you are going to substitute in a and b. So after substituting, you will get exactly 1 divided by z plus 1 plus 1 divided by z minus. We have separated. So the one value will be for z naught will be minus 1, the other value will be plus 1. Okay. Yeah. What is the radius? Any guess? Radius. Radius is here somewhere. Okay. Your radius is plus 1. And what is the origin? That also plus 1. Minus 1 somewhere here. So we are going to substitute for z equals minus 1 and that will become f of z naught. Where z naught will be minus 1. So f of minus 1. Okay, because this one lies outside the circle. So this will become 0. You will have only this alone. Okay, 2 pi I f of z naught equal to 1. So 2 pi I f of z naught. So you will get that answer as 1 plus 1 divided by z square plus 1. Z equal to 1. Okay, so 1 plus 1 that will give you 2. 1 plus 1 that will give you 2. So 2 divided by 2, answer will be 2 pi I. The answer is 2 pi I. Okay, so now we will go for another problem. Simple problem it seems. Z divided by z minus 2. Simple problem. Your mod z equal to 1. Your z minus 2. So z equal to 2. What of this mod z equal to 1? So whether it is analytic or not, we are going to check. We will see. Yeah, you are correct. So the integral z divided by z minus 2 dz, we are going to keep this as 1, equation 1. This is your integral formula. Okay, integral formula, you are going to keep this as equation 2. Now f of z divided by z minus 2. So f of z divided by z minus, this is your Cauchy's integral formula. Okay, now you compare equation 1 and 2. Where f of z will be z minus z naught equal to, as usual we know z minus 2, so z naught equal to 2. Z minus 2 is equal to 0, so your z naught will be 2. Correct? You compare these two, z minus z naught, so z naught will be 2. So z divided by z minus 2 dz equal to 2 pi I f of 2. So f of 2, as usual, answer is 0. So this is not analytic because z not equal to 2, whereas mod z equal to 1. So it lies outside. So the answer is 0. Okay. Now sin 3z divided by z plus pi by 2. What of your radius? Radius is pi. Z equals your z naught will be, of course, mod z equal to 5. What of z naught? Minus pi by 2. Okay, minus pi by 2. Whether it lies inside the circle or not? Minus pi by 2. Your pi will be 3.14. So 3.14 divided by 2, surely it will lie inside. So analytic function exists. We are going to see. So sin 3 z divided by z plus pi by 2. Now we know Cauchy's integral formula goes like this. Your z naught will be minus pi by 2, your f of z will be sin 3z. Is it okay? Very simple idea. And we know this equation becomes 2 pi I times f of z naught. We know. So f of z naught is nothing but we will have to substitute for z naught f of minus pi by 2. So wherever you find z naught, you will have to substitute minus pi by 2. We will find out. So sin 3z divided by z plus pi by 2 dz becomes 2 pi I z naught f of z naught. So mistake is there, f of z naught. So instead of f of z naught, minus pi by 2. So you have to substitute for this one also. So this is your f of z. You have to substitute. So this becomes 2 pi I sin 3 f of z naught. So sin 3 instead of z minus pi by 2. Sin minus theta equals minus sin theta. Cos minus theta equal to plus cos theta. You should remember. Sin minus theta. Sin of minus theta equals minus sin theta. Whereas cos of minus theta equal to plus cos theta. Plus cos theta. So sin of minus theta will give you minus sin theta. So minus sin 3 pi by 2. Is it okay? First point. I repeat. Sin minus theta equals minus sin theta. So minus sin 3 pi by 2. 3 pi by 2 is 270. Now you have to go only with the degrees. Sin is there. Earlier radian. At the time we discussed with 3.14. Pi is 3.14. Now it is degree. Okay. So this becomes 270. So minus sin 270. Is it clear? I repeat. Sin 3 pi by 2. So 3 pi by 2 becomes 270. Okay. Okay. Your pi is 180 degree. 180 divided by 2, 90. 90 multiplied by 3, 270. Shall I repeat again? I repeat. See, this is 3 pi by 2. Okay. Pi by 2. What is pi? Pi is 180 degree. 180 divided by 2 is 90. 90 multiplied by 3 is 270. So minus sin 270. Is it okay? Now, probably you would have studied earlier A sin cos tan. All silver, probably you would have mnemonic. Cups of tea. So this is a mnemonic. So you have A, all, you have sin will have only positive value, all the other terms will have negative values, cos will have always positive values in this quadrant. So this is one quadrant, this is another quadrant. So in this quadrant cos will have positive value, all sin and tan will be negative values. This value in this quadrant tan will have positive value, whereas sin and cos will have negative value. Now sin 270, correct? Sin 270 can be written as sin 180 plus 90. I can write like this. Sin 270 can be written as 180 plus 90. 180 plus 90, this is 180. So this is 90. Okay, 90. Is it okay? This is 90. So this term, okay, for cos alone it is positive. Now sin, so one more minus sign will exist. Okay, then for 180 and 360 we are going to have the conversion, sin will become sin itself. I repeat, sin 180 plus 90. Okay, sin 180 plus 90. For suppose we are going to add these two numbers, 180 plus 90. Okay, suppose if it is instead of 180, I can also with 90, I can also add with 270, 360, I can add. Suppose if it is 180 and 360, sign will not change into other term, sign will be as it is. For 90 and 270, sign will become cos, cos will become sin. For example, you have 1 degree. I am going to divide, I am going to separate. If it is 90 plus 60, sin 90 plus 60, 90 is there. So surely this will change into, sin will change into cos. Is it okay? There are two rules. One is positive and negative. Another rule is if it is 90 and 270, sine will become cos, cos will become sine. If it is 180 and 360, sine will be as it is, cos will be as it is. That's all. So now sine 270 lies in the third quadrant. Okay. So sine will be as it is, because 180 plus 90 as it is. So sine 90, it will become sine 90. What of this negative sign? Cos alone will have positive sign. So sine is there. So minus sine 90. Is it okay? Sine 90 is 1. So minus 1. So minus 1. This sign already we have written earlier. Sine minus of theta equal to minus sine theta. Don't get confused. So minus 1, they will give you 2 pi I. Otherwise, we learn this one in a physics way. This is mathematical way. We learn it in a physics way. Very simple way. This is sine curve. This is sine curve. We know already this is sine curve. Cos curve will start from here. Sine curve will start from origin, from 0. Cos curve will start from plus 1. Cos 0 is 1. Sine 0 is 0. So sine 0. Okay. Here it is pi. This will be 2 pi. One full curve. You would have learnt about wavelength for full curve. So 0, this is your pi, this is your 2 pi. So 0 to pi, in between what is this one? Pi by 2, sine 90. Sine 90 is 1. Sine 90 is 1. What is sine pi? 0. Sine 2 pi? 0. What is the in between? Minus 1. What is that one? What is that one? This is pi, as I said, minus 1 is correct. What is that one? What is the degree? This is pi. This is 2 pi. What is the in between value? 90 is here. Sine no. This is 270. See, sine 270. Sine 3 pi by 2. This is your pi by 2. This is your pi. This is your 3 pi by 2. The next one will be 2 pi. This is a simple way. See, this is, we can take it as physics and this can take it as from mathematics. Either way you can learn. Very simple. So sine 3 pi by 2. So exactly that is minus 1. I can written minus 1. Either way you can write. So the answer is 2 pi I. So sine 3 z divided by z plus pi by 2 with the integration dz is given as 2 pi. Any doubt? So last problem, I hope so. Okay, evaluate the integral cos z divided by z plus pi by 4 dz. The radius of circle is given as 4. So z equals minus pi by 4. You can check whether it lies inside or not. Pi by 4. Z equals minus pi by 4. So pi by 4, 3.14 divided by 4. What is the radius? Larger radius. 4. Surely the answer will exist. It is analytic. Okay. So Cauchy's integral formula goes like this. You have f of z is nothing but your cos z. Z minus z not equal to z plus pi by 4. Z not equals minus pi by 4. As usual, you will have to write 2 pi I times f of z naught. So f of minus pi by 4. So you have to substitute out. This is your f of z naught. So you have to substitute for cos, instead of z you have to substitute cos minus pi by 4. Cos minus theta equals, just now I said, plus cos theta. Just now I said. So this is plus. See, there is no minus at all. Minus sign at all. There is no minus sign. So it is plus. So 2 pi I times cos pi by 4. Cos pi by 4 answer is 1 by root 2. You will have to remember. Okay, 1 by root 2. Now I have multiplied divided by root 2. Okay, this root 2 and this 2, that will give me 2. This 2 and this 2 will cancel. So answer will be root 2 pi I. Simple. Root 2 pi I. I repeat, come on. I want to multiply and divide by root 2. This root 2 and this 2 root 2 will be 2. And here already we have 2. So that 2, the denominator 2 will cancel. You have only root 2 alone. So root 2 pi. Root 2 is nothing but 1.414 multiplied by 3.14. So what is the answer? 4.4. What is the radius? So the point lies outside the circle. Okay. We will have to see not only this, we will have to see this one also. Suppose if it is 1 divided by z plus pi by 4, then we can say that the answer will be will lie inside. We will have to see this one also. Here f of z in the earlier, suppose if it is 1 divided by z plus pi by 4, here f of z will be 1. Now it is f of z will be cos z. So which lies more than the radius. So the point lies outside the circle. Okay. That's all. So we will start today. So we have learnt cos is integration. No, complex integration. Then cos is integral formula. Then after that cos is integral theorem. So out of these theorems and formula, we have solved so many problems. Okay. Thank you, students. We will see you in the next class. Bye.